Hello and welcome to Fouraye Academy. Today I'll be doing a short video regarding to hedging. I wanna do a video related to the hedging ratio. So what the hedging ratio is if we imagine we have a $1 security, we'll name this A, and we wish to hedge it with H dollars of another security, which we would name security B. Then if you're buying the security, if H is negative, we are shorting the security. If H is positive, we are opening a long position. If H is negative, we are shorting. So how we do this is we first of all want to create a linear combination between the two assets or the two securities. So we have security XA and we have security XB. So we multiply one of them with H. So this would be the combination of these two. Now we want to create their combined variance, which would be variance AB would be equal to the variance of A plus the variance of B plus 2 times H times P times volatility A, volatility B. Or you could say standard deviation A, standard deviation B. So let's write that equation we just wrote again. Variance AB is equal to variance A squared, variance A plus variance B plus 2P volatility A, volatility B. Of course, we multiply them with H in this case. So we have variance A times plus H squared times variance B plus 2PH volatility A, volatility B. So what we want to do in this case, in order to hedge this portfolio and find the hedging factor, which is H, we want to take its derivative and set it to 0 in order to minimize the portfolio variance or portfolio volatility. So we would say the derivative of the portfolio variance with respect to the hedging factor H. So if you remember our equation, we had H squared times the variance of B. In this case, we use the power rule to get 2H variance B plus, remember we had 2PH volatility A, volatility B. Since H is to the power of 1, we drop the power of 1 to 1 and use the power rule to get 2P volatility A, volatility B. Also, I forgot to mention that P would be the correlation between asset A and asset B. So in this case, we set this to 0 in order to minimize it, and then we solve it for H. So the equation we got was the derivative of the portfolio variance with respect to the hedging factor being 2H volatility B, variance B to correlation AB volatility A, volatility B. Now we solve this for H by equating it to 0 as we said before, and by doing that we would get H is equal to minus P or minus correlation AB divided times volatility A divided by volatility B. And how we do this from the equation above is as such. We had the equation above right here. This would be equal to 0. In this case, we move that to minus 2H variance B equals minus 2P variance volatility A, volatility B. We divide this by 2 variance B squared 2, and this is volatility B times volatility B. So we have P times volatility A divided by volatility B equaling to H. But it's minus P, so you would get this. And this would give us the hedging factor of two assets. You could do this by creating a portfolio variance equation again for multiple securities and then minimizing it again. Now we'll be looking at an example question. This example question is from the FRM exam right here. We'll be looking at this question. So the question says that at November 1, Jimmy Walton, a fund manager of a USD 60 million US medium to large cap equity portfolio, considers locking in the fund's profit from the recent rally. The S&P 500 index and its futures with the multiplier of $250 are trading at $900 US and $910 US. So what we know from here is that we have a S&P 500 which is trading at $900, and we have S&P 500 futures with multiplier of 250 trading at $910. And Jimmy Walton wants to hedge these two, I'm guessing. Instead of selling off his holdings, he would rather hedge 2/3 of his market exposure. So he wants to hedge 2/3 of his market exposure. He would rather hedge 2/3 of his market exposure over the remaining 2 months, given the correlation between Jimmy's portfolio and S&P 500 index futures is 0.89, and the volatilities of the equity fund and the futures are 51 and 48. Respectively, what position should he take to achieve this objective? So with all of this knowledge, we can just plug it into the hedging ratio, which we learned to be minus P minus 0.86 times variance A. In this case, that would be, let's see, 0.51 divided by 0.48. This comes approximately to 9.45. This would be our hedging ratio. Let me bring up the question again. So we have our hedging ratio as 9.45, or let's just use 9.5 for ease. So he wants to hedge 2/3 of his market exposure. The market exposure is 60 million, so we get $40 million, which he wants to hedge. If you look at the ratio, it would be around $38 million. So he will be hedging $38 million at a short position, since this would be negative if we take this as negative as well. So what we did here is multiply this by 0.95 basically, and then we got this. And since it's negative, we will be shorting. So now what they want to know in the question is how many futures contracts they should short in this situation. Since we know how much money needs to be shorted, we need to calculate the price of one futures contract. It is trading at $910 with a multiplier of 250. That would roughly be $227,500. Then we need to divide $38 million by $227,500 in order to get the amount, which I think is roughly around 167 futures contracts. So the answer would be C. And that's it for the example question. And that's it on how to find the hedging ratio between two securities or two assets. Thank you for listening.